our lesson today is going to be, this is 3.1, this is the beginning of our new unit. We're going to be talking about function notation and patterns. So there's a couple different things I want to talk about. The first thing I want to talk about is what is a function? What is a function? Function. Okay, so with a function is going to look very similar to a lot of the things that we've already been doing. Up to this point, we've looked at two variable equations. We would have things like, y equals, 2/3 x minus 3, right? Up to this point, we would see that this is an equation. We'd understand it. We'd know how to graph it. We'd find its slope. We'd find its intercept, etc., etc. And we've been able to figure all that out. Okay, this is very close to what a function is. What we're going to do with a function is a function is a two-variable equation, but instead of having y and x, our y becomes f of x. Okay, f of x. So I would redisplay this equation. What I would say is f of x equals 2/3 x minus 3. Okay, this is the exact same information. It behaves the exact same way. The only difference is that we're representing this information as a function. Okay, and when we view a function, we're viewing it as a machine. Guys, everyone needs to be. If you haven't written down everything I've written so far, you should be doing that. Okay, a function is like a machine. Because look at what's going on here. We have f of x, and f of x is analogous to y. They behave similarly, but it's saying something different. Before when we would say y, what we were saying is there's some variable, there's some number on our y coordinate plane, right? Well, a function, we're saying something different. What we're saying is it's dependent on x, right? F of x is dependent on x. Right? So f of x, we would say, is our dependent variable. So f of x is the dependent. I'll move it up. Is that good?
Yeah.
Awesome. You can always count on Tessa to let me know when things are off view. F of x is the dependent variable. When that makes x is the independent variable. So what does that mean? What does it mean that x is independent and f of x is dependent? Dependent versus independent. Well, that means x can be any number. X, we can choose whatever number we want. It's independent. It's free. It has a holiday in July. It's like it throws fireworks and stuff. It does its thing. F of x is dependent on that, though. We can't just plug numbers in for f of x. What we need to do is we need to plug x into the equation to get our f of x. It's kind of like a machine. So when I say it's kind of like a machine, it's like a it's like a meat grinder. Okay, I always use this. It's like a meat grinder. Okay, this is our function box. I would draw it, function box. Okay, this is our function box. And here's what we do with our function box. We put things into our function box. And so what are we going to put into our function box? We're going to put in x's. We're going to put in an x, and we can put in anything. It's an independent variable. Independent. Our function is going to do things to it. It's going to mix it around. It's going to churn it up. It's going to add, multiply, subtract, divide, and then pops out our f of x. This is after it's been processed by the machine. Okay, it's kind of like you guys have like those filters on your camera phones, right? Like it'll do it in grayscale. It'll do it in like extreme color. It'll do it in reverse or whatever. That's a function. Okay, so it's like okay, here's a picture of me. I'm wearing my hat because it's hat day. There's my hat. Hi. There's a picture of me, right? And then you have your camera phone. You got your button. Here's the screen, and here's me with my hat on. Hi. Okay? And then you have all these functions that you can do on there. One might be, black and white. One might be, reverse colors. One might, I don't know, what else is there? Is there anything else? Those are like the big ones, right? There might be some other ones that you never use. Question mark and who cares. Okay? And so what happens is you take that, and if you do it in black and white, you get one picture. If you do it in reverse colors, you get another picture of me. You do it in orange, whatever the heck this is, mystery, you get some other picture of me, right? But the thing is, all of these different colors are different functions. The original amount, the original thing, is the same. That is the x. The x goes in through the camera, and based on the function, whether it's black and white, then I get this. If it's reverse, I get this. If it's our question mark, we get this. Based on the function, we get different values out. We get different values out of it. So let's look at what I mean by this. So I'm going to use that same example we've already been using. So I have f of x. Here, let's do an example. So if I have f of x equals 2/3 x minus 3. And say I'm curious, I don't know what this function is, but let's say I'm curious what this function does when x equals 3, we'll say. Okay? So what I'm going to do here is I'm going to say f of 3 equals 2/3 times 3 minus 3. 2/3 of 3 is 2 minus 3 is negative 1. So I know that f of 3 is negative 1. Does that make sense? All that we did is we chose a number for x. Maybe it was the reverse color. So here's x, here's x. I decided x equals 3. So instead of writing x, I wrote 3. All I did was substitute 3 in for x. And this right here tells me what I'm doing. So I say that f of 3, and that's how I say it. I say f of 3. That's how you say it out loud. F of 3. F of 3 equals negative 1. Any questions on this? Thumbs up if you want to see another example. Thumbs down if you're like, Victor, I get it. It's just like everything else. I need to see everyone vote. Another example? I see a lot of people asking for another example. Okay. So instead, I might have the same equation, f of x equals 2/3 x minus 3. And I might ask you, what is f of 2? You're like, okay, f of 2. All right, so I have f of 2 is going to equal, well, you see right here, all I did is I wrote a 2 where x was. All that's telling me to do is substitute 2 in for x. So 2/3, well, here's the x. Instead, I'm going to write 2 minus 3. 2 times 2 is 4/3 minus 3. That's going to be 3 over 1, 3 over 3. So 4/3 minus 9/3 is going to be a negative 5/3. So I know that f of 2 is a negative 5/3. F of 2 just means where my x was, I'm now putting in a 2. So that means where my x is, I'm now putting in a 2. Easy enough. Any questions on that? Awesome. Okay. So, that being what it is, our next part that we need to focus on are patterns. Okay? And so for this, I'm going to go back to the pattern that we were talking about today in the growing dots example. So I had 1 dot at start, 1, and then it grew into an x at 1, and then it grew into a bigger x at 2. Okay? And we were able to see, and we talked about it, what we saw was that every step we added 4. Plus 4, plus 4. And we could tell that it's going to be plus 4, plus 4, plus 4 for as long as we wanted to do plus 4s. All right? So it's important that when we have these, we're also building a chart that goes along with it. We're kind of doing it in our heads for these simple ones, but we could see that if the numbers got bigger than 4, we could easily start to lose track. So what we would have for this chart is we would have the time, the dots, and then the growth. Okay, times, dot, growth. Now time and dots, these could change based on whatever your variables were. But here we have time. Well, what time is this here at the start? We'll say that's 0. And at 0, we had 1 dot. At time 1, we had 1, 2, 3, 4, 5 dots. And how did we get there? Well, we had our 1, and we added 4. At time 2, we had 9 dots. And how did we get there? Well, we had the previous step, which was 1 plus 4. Yeah. And then we added another 4 to it. Thank you. So at step 3, we would have what? 13 dots. And that's because we had the previous step, 1 plus 4 plus 4. And then we added another 4 to it. Okay? Now, this right here, constructing this, can be very tricky for some students because all that it is it's writing down what we kind of know intuitively, right? We can just look at this and see, hey, we're adding 4 each time. But this is taking that abstract idea, which we don't realize is so complicated at first, right? We see it, we're like, oh yeah, you add 4, that's simple, Victor. But when we actually break it down to what we're doing each step, we can see that it's actually kind of complicated. So for example, if we had time t, which was a variable, we saw that that was what? That was going to be 4 times t plus 1. Right? How did we know that? Well, it wasn't that hard. We saw that there was 1, 1, 1. There was always a 1. And so that's how we got that answer. But then also, at time 1, we had 1 4. At time 2, we had 2 4s. At time 3, we had 3 4s. So surely at 4t plus 1, we would have a number of plus 4s based on how many t's we had, in addition to the 1 that we add on. Okay? That is how we constructed that. Guys, make sure this is in your notes, this pattern. We will return to this over and over again as we start to do more complicated patterns. I'll go ahead and leave this up on the board while you guys get started so that you guys can see it. If anyone needs to see it up close, I'm happy to hand it out to you. But I'm going to stop the recording so that I can help you guys on the homework specifically.